Hey everyone! Have you ever wondered how something complex, like a character in a video game or your banking app, actually gets built? Well, it all starts with a pretty simple idea. You take something from the real world, you create a super detailed blueprint for it, and then you bring that blueprint to life inside a computer. And today, we're going to unpack that exact idea using one of the most powerful programming languages out there, C++.
So let's start with a question. How would you teach a computer what a car is? I mean, a computer has no idea. It just sees ones and zeros. We need to tell it everything. We have to give it a list of its properties, its color, its price, and also what it can do, like start, drive, and stop. This is where object-oriented programming comes in. It gives us a really organized, powerful way to do exactly that.
Before we write a single line of code, we need to put on our architect hat. The very first step is to model the world around us, and we do that by breaking it down into these distinct objects. We have to ask, what are the key things that our program needs to understand and interact with?
And what's really cool here is that an object in programming isn't just for physical stuff like a car or a pen. It can also be a totally abstract concept. Think about a bank account. You can't physically touch it, right? But it definitely has properties, like a balance and an account number, and it has actions you can take, like deposit and withdraw. Okay, so we've got our model. How do we translate that into something the computer can actually work with? Well, we need to create a formal blueprint. And in the world of C++, that essential blueprint is called a class. A class is basically the master plan. Now, it's super important to get this. The class itself is not the finished product. It's just the template. It defines all the potential properties, which in C++ we call attributes, and all the possible actions, which we call methods. It's the perfect design for whatever it is we're about to build.
And here is where it all just clicks. Look at this comparison. On the left, you've got the human-friendly blueprint, and on the right, you've got the C++ class. See that direct translation? The properties like company and color become data variables, our attributes. The actions like start the car become functions, our methods. We are literally translating a concept into code.
So we know a class is a blueprint, but what's actually inside? Let's pop the hood and take a look at the anatomy of a C++ class. We'll see how it organizes and, maybe even more importantly, how it protects its information.
One of the most powerful ideas in object-oriented programming is something called encapsulation, or data hiding. Think of it this way. A car designer doesn't want the driver to be able to just reach in and randomly mess with the engine's timing. A class lets us protect the really important internal workings of an object from the outside world. This distinction between public and private is absolutely critical. Just think of the public parts as the user interface of the car, the steering wheel, the pedals. Anyone driving the car can use them. But the private parts, that's the core engine stuff, the timing, the fuel injection. That stuff is locked away and should only be accessed by the class's own internal functions. This is amazing because it stops other parts of your code from accidentally breaking something they have no business touching.
Okay, our blueprint is complete. The design is perfect. Now it's time to fire up the assembly line. We're going to take this one single plan and start creating actual, unique objects from it. This is where it gets really fun.
And there it is, an object. It's a real, living, breathing instance of a class. If the class is the blueprint, then the object is the actual car that rolls off the assembly line. It's really just a variable, but its type is the custom class that we design.
So the very first step is to define our blueprint in the code. We start with this line, class car dot. And inside those curly braces, we'd list all the attributes and methods we just designed. Now remember, this step doesn't create any cars yet. It just teaches the computer how to build a car.
And now we create our first object. This single line of code right here, car Honda City, tells the computer, hey, go find that car blueprint and use it to create a brand new object in memory. And let's name it Honda City. And just like that, our first car exists.
And the real power here is that we're not just limited to one. With another simple line, car Hyundai i20, boom, we've got a second, completely separate object. And even though they're made from the exact same blueprint, their data is totally independent. If we change the color of the Honda City, it has zero effect on the Hyundai i20.
And of course, we can do it again with a Sumo Grand. This is the absolute essence of reusability. We do the hard work of designing the blueprint just once, and then we can create an entire fleet of unique, functioning cars with hardly any effort at all.
All right, theory is great, but let's see how all these pieces, the class, the object, the methods, actually come together in a simple, complete C++ program.
Let's see it in action. Now, before we look at the full program, there is one last crucial piece we need to know about, the constructor. This is a special method. It actually has the same name as the class, and it runs automatically the instant a new object is created. You can think of it as the ignition sequence. Its job is to set up all the variables and get the object into a good, stable starting state.
Okay, let's trace the flow of this code. We start with our test class blueprint. Then we jump into main, which is where our program starts. The line test01 brings our object to life, and that automatically calls the constructor behind the scenes. Then we use the dot operator, that little period you see, to access the object's public functions. We're basically saying, hey O1, run your setData method, and then, okay O1, now run your displayData method. It's a really clear logical path from creation to action.
So we've seen the what and the how, but let's just take a moment and wrap up with the why. Why do programmers go to all this trouble of creating classes and objects? What are the real game-changing advantages here?
So why does all this matter so much? Because this whole blueprint approach is a complete game changer. It gives us organization by bundling related data and the functions that act on that data into one neat package. It gives us incredible reusability. We write the code once, and we can stamp out thousands of objects from it. Data hiding, through that encapsulation we talked about, protects our objects from being misused, which makes our programs way more stable and reliable. And at the end of the day, it just gives us a powerful and intuitive way to model the complexity of the real world right inside our code.
Ultimately, a class is just a tool for turning your ideas into reality. You know, whether that idea is a character in a game, a transaction in a finance app, or even a simulation of a planetary system, it all starts with a blueprint. So the only question left to ask is, what blueprint are you going to design first?